Lesson 8 for trigonometry. This is one of those lessons that you actually will use in real life, possibly, maybe, depending on what you're going into. So it is important to learn because they still use this despite technology. Trigonometry is broken down into the sine, cosine, and tangent of an angle. So everything is referencing this angle A down here. And this word up here, Soh-Cah-Toa, that is to help you remember the ratios. So it kind of sounds like a ninja. Soh-Cah-Toa. So anyways, sine, the sine of an angle, is represented by the side opposite over the hypotenuse. So the sine of A is opposite over hypotenuse. Cosine, the cosine of an angle is the adjacent side over the hypotenuse. The adjacent over the hypotenuse. And the tangent of an angle is the opposite over the adjacent. The tangent of A is the side opposite over the adjacent. What that means is you are going to use your handy-dandy calculator in this lesson to use the sine, cosine, and tangent functions. So let's look at this a little further with example 1. We have the sine, cosine, and tangents of specific angles, and we are going to express those ratios as a fraction and as a decimal. So if I'm focusing on angle L down here to find the sine of the angle, the sine is the opposite 12 over the hypotenuse 37. So in my calculator, to find the sine of that, all I need to do is put in 12 divided by 37. And we're going to round it so it's about 0.32. Okay, well let's look at the cosine. The cosine of my angle, cosine is adjacent over hypotenuse, which is about 0.95. And then the tangent of that same angle, tangent is opposite over adjacent, and that is about 0.34. All three of those trigonometric ratios are talking about the same angle, angle L. But the next three, we're going to switch up here to angle N. So our ratios are going to be a little bit different. The sine of N, sine is still opposite over hypotenuse, but now the side opposite is 35. So the sine of N is 35 over 37, which is about 0.95. The cosine of N, now 12 is the adjacent side. 12 over 37 is about 0.32. And then lastly, the tangent of N, tangent is opposite over adjacent. So 35 over 12, and that is about 2.92. Okay? So let's look at example 2. Example 2 says use a special right triangle to express the cosine of 60 degrees. So you have to ask yourself, is this a 45-45-90 triangle, or is this a 30-60-90 triangle? So let's draw that out. If it's 30-60-90, here's what it looks like. And think about last lesson, we had specific side lengths. The 30-degree side is x, the 60-degree side is x roots of 3, and the 90-degree side is 2x. I want to find the cosine of 60 degrees, this right here, this angle. So cosine of 60, remember the cosine is always the adjacent side, so x, over the hypotenuse, 2x. Using a little bit of my algebra skills, my x's cancel, so I have 1/2. I also need to express this as a decimal, so 1/2 is 0.5. Now what's interesting about this, no matter what triangle you have, doesn't matter the side lengths. If you put in the cosine of 60, it's always going to be 0.5. That's one of the cool things about trigonometry, is that your ratios never change. It's an absolute. It is constant. Okay, let's try example 3. Now, on this example, your teacher forgot to put the degree and the arrow. This 7 goes to that little tiny angle. Okay? And one of the things you have to notice is it's asking you how many inches. So we want this side in inches, but this side is in feet, the actual treadmill. So first thing you need to do is change 5 feet to 60 inches. Okay. Now we have inches and inches, and life is beautiful. I need to find this side over here, but I don't know this side to do Pythagorean theorem. It's not a special right triangle, so I have to use Soh-Cah-Toa to solve it. So I have to ask myself, am I going to use sine, cosine, or tangent? And that's where I'm looking at this angle right here. This is the angle I'm using. So I have this side opposite, and I also know the hypotenuse. That sounds a lot like the sine function, and it is. The sine is opposite over the hypotenuse. What I'm doing is I want to know the sine of 7, because it's the angle. I already know the angle degrees, equals the side opposite, which I don't know, so that stays y, over the hypotenuse, which is 60 inches. I need to find out y. So let's do a little algebra, rearranging. Multiply both sides by 60. Those cancel. And if I rewrite it, I get 60 times the sine of 7 equals y. Here's where your calculator comes in handy. What you're going to put in is exactly what you see. 60 sine 7. Enter. Okay, that's a long decimal. So it says approximately how many inches. So we're going to say about 7.3 inches. Make sure you label it. Okay. There is also something called inverse trig ratios. On your calculator, if you notice above the sine button, cosine and tangent, there is a sine to the -1, and a cosine to the -1, and a tangent to the -1. These are your inverse trig functions. This is what you need to use if you need to find the angle. So far we've just needed to find the side, but if you need to find the angle, you are going to use these. For example, if the sine of A equals x, your inverse sine, the inverse sine, or sine to the -1 of your side, your ratio, equals the measure of your angle A. Okay? Inverse cosine. If the cosine of A equals x, so you know the angle, the inverse of your ratio equals the measure of your angle. And the same is for tangent. If tangent of A equals x, and please scratch out cotangent. That was a teacher typo. Inverse tangent. Tangent of A equals X. Then the tangent, the -1 of X equals A. That's all great on paper, but what the heck does that mean in a problem? Well, we have an example to tell you what that means. We want to find angle P. We don't know how much that angle measure is. We know this is 90, and that's all we know. We know the adjacent side to the angle, and we know the hypotenuse side. So which trigonometric function is that? Sine, cosine, or tangent? Yes, it's cosine. So we're going to write this out. The cosine of P equals adjacent over hypotenuse. Let's fill in what we do know. Do we know the measure of angle P? No. Do we know the adjacent side? Yes. Do we know the hypotenuse? Yes. So here's where our inverse trig functions come in handy. We are going to rearrange this so that we can find the angle. So we're going to write it as cosine to the -1 of our ratio 13/19, and that is going to equal P. How do you put this in your calculator? Remember those functions I told you about? You have to do second cosine, and then we're just going to put in the ratio 13/19 and hit enter. That is how big angle P is. It is about 46.8 degrees. So P is about 46.8 degrees. Okay, let's practice that a little more. We're going to solve a triangle. All the missing sides. Okay. AB is going to be the easiest to find. Because we know these two side lengths, we can use Pythagorean theorem to find AB. So remember, it is the square root of these two sides squared. The square root of 7 squared plus 4 squared. So what is 49 plus 16? Is 65 a perfect square? No. And normally I would tell you to either leave it or factor some stuff out, but it says to round it to the nearest hundredth. So you do want to actually figure out what the square root of 65 is, and it is about 8.06. So now that we know AB, we can figure out our angles. Let's do angle A first. Okay, so angle A right here, I don't really want to use AB only because it is an approximation. So I really want to stick with only using 7 and 4. So given that, I know the side opposite, and I know the side that is adjacent. So that sounds like tangent. So let's write this. The tangent of A equals 4/7. Well, I don't know what A is, so I have to use my inverse tangent button. So again, on your calculator, put in inverse tangent 4/7. 29.7. Now it says to round to the nearest degree. So we're going to round this up to 30 degrees. So if angle A is 30, do we have to use trigonometry to find angle B? You can if you want to practice it, but you can also know that there are 180 degrees in a triangle, so angle B is about 60 degrees. Okay? And you can kind of see that 8.06 is almost twice as much. So remember, we rounded to the nearest degree. So pretty close to what we talked about last section. So again, here's our concept summary. Remember, Soh-Cah-Toa. And remember, inverse trig functions are used to find an angle measure.